with the next concept, that is lateral inversion. As we have already discussed regarding the lateral inversion, children. So what is lateral inversion? What is lateral inversion? The phenomenon of appearance of left towards right, whereas right appears towards left. This phenomenon of appearance is called as a lateral inversion. Okay, children. So let me write the definition. The phenomenon of left appearing towards right and right appearing towards left. Left is visible as right side, whereas right is visible as left side whenever seen in, when does it happen? Whenever you look into an object in a plane mirror. So whenever we see an object in a plane mirror, the left side of the object appears towards right side, whereas the right side of the object appears towards left side. This phenomenon is called as your lateral inversion. To understand this clearly, let us take few examples. First of all, let us discuss something regarding the alphabets, and then we shall also discuss something regarding the numerical values. So let us discuss this in detail. Okay. For this, let us consider mirror-like structure. Let us consider mirrors as described, in front of which let us keep the alphabets. This is the position of A, B, C, D, E, F, G, H, I, J, K and L respectively. So I have written few letters, children, A, B, C, D, E, F, G, H, I, J, K, L. Let us extend our letters. Some M, N, O, P, Q, R, S, T, U, V, W, X, Y and Z respectively. Yes. So if you observe the same letters inside a mirror, let us see how it looks like. Here we go. Suppose if you observe the letter A inside a mirror, the right side portion of the A, the slanting position, will appear towards left like this, and the left side portion inside a mirror appears in this direction. Hence, and the middle line as it is. Okay. That means the letter A when inverted, the letter A when laterally inverted appears in the mirror something like this. So, two slanting positions in between which it is joined by a horizontal line. So the letter A almost appears as it is. But whereas if you consider the letter B, the left side portion of the vertical line will in the image will be caught at the latter side, and the curved position of the B is observed something like this. Okay. So the image B, when observed inside the C, the curved position will be facing together and the vertical lines at the later side. The C something like this, D here, the value letter E, F, G, H again appears to be same, the letter H as it is, letter I, J, the curve will be in the reverse direction, K, the slanting lines towards facing each other, L, M again looks alike, same structure, N, a small slight difference is being observed in the N, O, similar, P changes, Q changes, R, S, T, U, V, W, X, Y and Z. If you observe this, A similar, B is changing, C the curve are facing together, D curve is facing together, E facing together, F, G, H appears alike, I appears alike, J opposite direction, K, L in the opposite, M as it is, N as it is, O as it is, P again curve facing each other, Q different, R different, S different, T, U, V, W, X, Y similar, whereas Z is changing. That's it, children. Yes. So, from our observation, we see that A, H, I, M, O, P, T, U, V, W, X, Y have same appearance when seen in the mirror. But all others, the position are changing. Okay. So, among the given alphabets, which alphabets does not show lateral inversion means the letters A, H, I, M, O, T, U, V, W, X, Y does not show lateral inversion. Similarly, if we also observe the letters, numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0, 1 shows the lateral inversion, 2 also shows the lateral inversion, 3 also shows the lateral inversion, 4, 5, 6, 7, 8, 9 and 0. So, among the numbers, the 0 as well as 8 does not show lateral inversion, but all other numbers will show lateral inversion. So, I hope you understood what exactly the lateral inversion is. The left appears towards the right side, whereas the right appears towards left side when seen in the mirror. Okay. Well, so children, while extending this topic, I just wanted to know, did you ever observe the letters on the ambulance? So, how the letters are being written on the ambulance? You would have observed that the letters on the ambulance were written something like this. Did you ever observe the letters on the ambulance? They will appear something like this. What is the reason behind this, children? Well, let me tell you the reason. So, generally, who will be carried by the ambulance? Of course, patients. And you know that patients who are fighting with their health. Okay. So, maybe, so children, so the letters on the ambulance are written as shown. The reason for that is the patients who are fighting for their life are carried by the ambulance in general. And we also know that whenever an ambulance passes by on the road, it is the responsibility of every citizen to keep aside and give way to the ambulance so that the patient can be reached to the hospital on time and can be saved. Isn't it? So, in order to identify the vehicle as an ambulance, those people, the drivers will not turn back. They simply look into their mirrors. That is, they are called as rear view mirror, which is attached at the driver's place. Okay, vehicle. At the vehicles, you see, towards the right side, a mirror is being attached to the vehicles, whatever the vehicles, whether it is a bike, scooter, or a vehicle, car, or anything you observe, lorry, truck. So, the persons there observe the vehicles passing by them inside the rear view mirror. So, if it happens to be the ambulance, they will give a path to them. They will give away them. So, in order to observe that vehicle name in the mirror provided at the driver's place, those letters in the mirror are laterally inverted. When the letters are laterally inverted, whenever this person, the driver, sees those letters appears to him something like this. The appears for the driver appears something like this. So, how do they appear to be? This A appears here and M, B, U, L, A, N, C, E. Okay, so whenever the driver observes those letters in his mirror, those mirrors appear him as a complete name as an ambulance. So, this person, the driver, identify it as an ambulance, and so that he can keep himself side away. So, this is the reason behind that. Got it, children? Okay, so anyhow, moving to the next concept regarding the displacement and velocity of the image with respect to the object. Our next concept is all about the displacement and velocity of the image with respect to the object. So, first of all, if you want to discuss something regarding the displacement of image with respect to object. Displacement, let us generally, the displacement can be occurred, the image displacement or the object displacement can happen in 3 dimensions. One is perpendicular to the mirror. So, the mirror is lying like this and the person may be moving perpendicular to the direction of the mirror. And another 2 things is parallel to the mirror, parallel in the sense in the plane of the mirror. So, let me explain in detail regarding this. Whenever, so 3 dimensions I told you, one is along the x-axis, the other is along the y-axis and the third is all along your z-axis. Okay. Suppose that if this happens to be your x-axis, y-axis and z-axis and here is your mirror. Whenever a person moves along the x-axis, then the image also moves along the x-axis. So, whenever a person moves along the x-axis, front or back, we observe that the image also moves along the x-axis, front or back. As and when this person coming forward, the image also comes forward. This is your image, children. This is your image and this is your object. So whenever a person moves perpendicular to the plane of the mirror, perpendicular to the plane of the mirror, we observe that image also moves perpendicular to the plane of the mirror. But in which direction? If he moves in the forward direction, the image moves in the backward direction. What I exactly mean that? If the object moves in the towards the left side, so in the number line if you observe, x-axis and y-axis, then this indicates your positive values and here indicates your negative values. So whenever a person object moves towards negative side, we observe that the image moves towards positive side. If the displacement of the person along x-axis is taken as a negative, the displacement of the image along x-axis is taken as positive, but the magnitude remains same. So whatever the distance covered by the object, same distance is covered by the image but in the opposite direction. Hence we can conclude that the distance travelled by the image, along x-axis is equals to but opposite to the direction of the distance travelled by the object. But whereas if it happens to be along the y-axis, y-axis, upward direction we take it as positive, whereas downward direction we take it as negative. So whenever a person starting from here moves in the upward direction, then the image also moves in the upward direction. So if this happens to be positive, here also it would be positive. That means along the y-axis, if you observe, the distance travelled by the image along the y-axis is also positive. The distance travelled by the object along the y-axis is also positive. So both are positive values. So no need to represent this. So only thing we observe that is this, whenever the person travels perpendicular to the plane of the mirror, the sign changes. But parallel to the plane of the mirror, upward and downward direction remains same. Positive and positive. The same happens to be with the z-axis. Z-axis means, so if the person moves in the cross direction, here also it moves in that particular direction. So same this way. Z-axis means, here I am not able to show you, but actually the thing is that if the person shifts front and back, something like this, parallel to the plane, the mirror will be something like this, and if the object is moving like this, moving forward means image also comes forward, moving back means image also moves back. So same direction. So while comparing the position of the image along z-axis, there is no changes we brought. Only when the object moves perpendicular to the plane of the mirror, then the position of the image and object will be in opposite direction. Whereas whenever the object moves parallel to the plane of the mirror, that is up and down or forward and backward, then the direction also remains same. So this is what our observation regarding the displacement of the image with respect to object. So what is that, children? Displacement of the image with respect to object is the same. Similarly, if you want to understand the concept regarding the velocity of image with respect to object, just to take the derivative thus, as the time passing on, derivative of this is dx by dt indicates the image velocity along x-axis equals to object velocity along x-axis but in the opposite direction. Similarly, image velocity along y-axis is equals to object velocity along y-axis, and image velocity along z-axis equals to object velocity along z-axis. Only thing again, as here the direction is changing, here also direction changes accordingly. All other values remains in the same ratios. This is all with respect to the observation whenever we measure it with respect to a mirror. So, the distance of the image, displacement of the image with respect to the object with respect to the mirror. Similarly, velocity of the image, as the relation between the velocity of image and the velocity of object with respect to the mirror, because the mirror is stable. But the same observation, if it is done with respect to the observer, mirror is different, observer is different. The same is observed with respect to the observer. If the person moves by speed v, forward or backward, image also comes forward and backward with the same speed v. That means speed and speed together, when the person sees, the difference he observes is 2 times. Okay. In that case, when it is observed, the same is observed with respect to the moving observer. Observer in motion. Observer in motion, the speed of this will now become, minus 2v times of the object along x-axis. Other remains same. I hope you understood, children. So, the first concept what I have explained you is, so with respect to the stable mirror, when we observe that, v will be minus v. But with respect to the moving observer, if you observe the same condition, the speed will be double to that, that is minus 2v. Okay, I hope you got the clarity regarding all the concepts on this. So, based on that, let us move to the worksheets on this concepts we have discussed. So, let us discuss something in detail regarding the worksheet 3.